Welcome to my YouTube channel, and today I'm going to talk about the brain of the game AI. When you play games such as GTA, Far Cry, Assassin's Creed, Uncharted, have you ever wondered why NPCs just walk around without hitting walls, trees, or why enemies will find the best path to come and attack you? All this is driven by an algorithm called the Dijkstra algorithm. And in this video, I'm going to explain it to you. So watch until the end because the end is where it gets interesting. So what is an Dijkstra algorithm? What does it really do? Imagine a traveler trying to reach a destination on a map. They want the shortest path. They want to avoid dead ends. They want to move smart, not just fast. And an Dijkstra algorithm helps them to do that. And it does this by exploring the path that looks promising, avoiding paths that are too costly, and using a smart guess heuristic to guide the search. A promising path means a path close to the goal, a path with low cost zones, and a costly path means a path with too many steps or moves, or a path with an desirable terrain. For example, when you play a game, you'll see that when enemies want to attack you, they will choose the best and the shortest path towards you. If the path has an obstacle, they will not take that path. For example, in games such as Assassin's Creed, when you climb on top of a building and there are two options to get to you: one, a ladder, and two, climbing doors, walls, so that you can get to the roof, you will realize that the enemies will use the ladder and they won't use doors and windows because it is riskier and they might fall and their health will reduce and they will die. So they will choose the promising path and leave the costly path because it has an undesirable terrain, or maybe many steps or moves to get to you are required. So what are the core building blocks of an Dijkstra algorithm? We have a node, is a point or a position in the graph, especially in 2D games, or a point in 3D space where a player can interact with or move towards with. An example is a door. When you walk towards a door in a game and you interact the door to open it and get inside a building, the door becomes a node. And then the edge is a path between two nodes, for example, a road, or for example, in Assassin's Creed. I like using Assassin's Creed because I love the game. When a player jumps from a building to a haystack or a bush, that distance from the building to the haystack is also an edge. And then a search space is a set of all paths an algorithm can explore from start node to goal node. And then open lists are nodes we are considering to search. And then closed lists are node we have already searched. And then we go to scoring paths. Scoring paths is the act of calculating how good a path is from start to finish and estimating how good it might be to the finish goal. And then we have the trinity of the Dijkstra algorithm path scoring. And we have the G bracket N. This is the actual cost from start to end node. And G denotes the actual cost of traveling from start node to current node, and N denotes the node. H bracket N estimates, it is the estimated cost from the start node to the goal. H denotes the heuristic functions and N denotes the node. And then we have F. It is used to rank paths and choose the next goal. F denotes the full cost of a path through node, and N denotes the node. And then how to calculate G in the formula G bracket N. So if this is If what you're seeing on your screen is an example of a path setup, A, the starting point, B, an intermediate node, and C, it's the current node being evaluated, or the end node. So cost, the cost the cost is the effort, the time, the distance, and the risk, or the resource usage needed to move towards the node. So what you see here below is the formula used when you are calculating the 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 G in the formula. How to calculate H in H bracket N. So calculating H depends on your movement system. In grid 3D world, climbable surfaces etc. Common heuristics include, now in Man in Manhattan distance is mostly used in 2D. Think in blocky movements such as, let's say, a chessboard. There is no diagonal movement allowed. It is used in grid-based games like classic Zelda or Pac-Man. And then we have the Euclidean distances. And in Euclidean distances, it is used in realistic 2D or 3D worlds where you can move in all directions. Perfect for Assassin's Creed, and where you can run, jump, and climb freely. When you look at the formula, it has to start with a square root. Although I haven't placed it there, it's supposed to be a mistake, but it's supposed to be square root bracket x1, the x is a value, minus x2, the x is also a value, plus y1, y is a value, minus y2 squared, y is a value. And then we have the octile distance. It is the max d change in y in x, change in y, plus 0.414 times minimum change in x over change in y, where change in x is equals to absolute. Absolute means you cannot have a negative value because there are no negative steps. X is a value, minus x is a value, and y is also a value, minus y is also a value. It is used in grid games where diagonal moves are allowed, more accurate than Manhattan in such cases. And then what is ABS? ABS stands for absolute value. It simply means ignore the minus sign. Always give me positive version of a number. And then we have the last trinity where it's Fn, and it's calculated by the formula F bracket n is equals to G bracket n plus H bracket n. And F means the full cost of a path through a node. So I'll be talking about this much deeply, and I'll have more videos about this algorithm. If you want to know more about the algorithm, wait for more videos that I have for you. And thank you for watching until the end. And please subscribe to my channel if you love games, if you love game development, game algorithms, system programming, everything related to game development. Please subscribe to this channel. Thank you for watching.